Hello everyone. I thought I would give you a short tutorial on how to use Excel. I know many of you have not really used this tool before, and we will use it quite often in this class. So if you have some experience with it and know how to manipulate the data and how to use equations, it can be quite valuable. So when you get into Excel, what I've done here is I've put into these cells some data, and I'm going to show you how to use equations, and I'm going to show you how to do some graphing. So let's first talk about cells and equations. So if I have data in these cells right here, I've got some X data and some Y data. If I want to write an equation that takes into account this data in the first column, let's say I want to sum up the data in the first column. The way that we write an equation is inside of a cell, we start any equation with an equal sign, and then we write the equation name. And you can go out and Google Excel equation names. There's a lot of them, and I think it's also possible to get it in the help menu in Excel. But I'm going to show you a few that you'll use often. But I put equal sum, and then you notice this next part, C5 ... C14 means I'm taking the data in column C, row 5 through 14, which is this data right here, and that's what is put there. So let's say I want to come over here and I want to do it for this column here. I might put equal sum, left parentheses. I can either highlight it like that and it automatically adds it in, or if not, maybe I just want to do it by hand. I can do D5 to D14, right parenthesis, hit return, and there's the sum of all the data in this column right here. So I'm going to clear this for now. Count is another thing I like to use. If I want to count the number of data variables I have, I can use a count. Average or mean, you will use this one quite often. So I take the average of C5 to C14, that's 30.7. Standard deviation, you'll use this one a lot. So the one we use is the standard deviation .s, which is for the, it's for a sample as opposed to the entire population. It's very common in our class. We will do standard deviations using the sample formula, which is not always indicative of the entire population. So therefore, we will be dividing by n minus 1. And if you're not sure about that, you can put equal standard deviation, you click there, and if I click on the little blue equation right here, it gives me everything I need to know about the help topics and on that equation. So let's get rid of that one. That's standard deviation of these numbers right here. And then if I wanted to take the square root of any number, I could do equal square root of a single cell. So the square root of 307 is right here, 17.52. Another little trick in Excel is you don't have to re-type in a formula. If I've got a formula for the X column, if I copy it, do a Control-C, Control-V, copy-paste, I have now copied this formula over to this location, and it automatically updates it and takes the sum now of this second column. This is the sum of the X column, this is the sum of the Y column. I can do this for all this data. So I just highlight it, copy, paste, and it now has summed up all, or it has moved over and recopied the formulas underneath. So this is now the standard deviation of this data up here. And if you look and see, if you click on a cell and you see the formula bar at the top, the formula bar shows you exactly what it is. Sometimes the default is not to view. Make sure you have view formula bar on your menu. Okay, so the next thing I want to show you is how to do some graphing. This is also something we'll do in our class. In the first couple weeks, you're going to be doing some things like bar charts, column charts, or pie charts. So here's some data I have here where this is the label for the data and this is the count. All I do is I highlight the labels and the counts, and I do insert chart. These are the types of graphs, insert chart, and the one we use the most is going to be a column chart. It's not a bar chart because a bar chart does it sideways. The column chart does it up and down, and I do that, and now I have my perfect chart. Let's go do that again. So I just deleted that. Let's do insert chart pie. There's a pie chart. Notice it has the colors labeled below, and it has the perfect pie representation of the numbers you see here. And then finally, let's do an XY plot, linear XY. This is something you're going to get here in week 7. So I take the X and the Y data, I put it into 2 columns, highlight all of the data, do insert, chart, XY scatter, and there it is right there. There's my XY scatter plot, and I have the data. So what if I want to get the linear model or the linear equation of this data and the R-squared determination coefficient or correlation coefficient? I'll show you how to do that. I click on the data points, so it highlights them all. Then I right-click and I do add trend line. There's other ways to add a trend line, but this is my favorite way. The default is a linear trend line, and at the very bottom you will see display the equation on the chart and display the R-squared value on the chart. And if you do that, it automatically displays it. I'm going to move it over here. I come over to this box, I'll go back to my home, so I get my home menu. I can make it bigger by clicking the font size. And look what we have. So in the end, I've got my scattered data, I have my linear model, here's the equation of my linear model, here's the R-squared coefficient. Now, we often use that R-squared coefficient, it's called the coefficient of determination. You'll see when we get to chapter 7, we often look for what's called the correlation coefficient, which is the square root of this number. So let's say if we have 0.96095, that's what I have above. If I want to take the square root of that, I use my little formula, equals square root, left parenthesis, highlight that block, right parenthesis, hit return. 0.9802 is the R value of this data, which is the correlation coefficient. And as you will find out later, a correlation coefficient close to 1 is a very good fit. And you can see that this line fits the data really nicely. And now lastly, I want to jump on over to probability distributions. And in Excel, sometimes we use tabs. So I have this data in a different tab. So during week 4, 5, and 6 in the class, you're going to see some other equations that you might use. If I want to find data from a normal distribution or a student t-distribution, these are some of the formulas you will use. I've written down what the formula is. You see how it uses the equal sign, what the format of the data entry is, and an explanation of the result. So here's some examples below. So here's the formula if I use. If I click over here on top of this cell, you see up here in the formula bar, the formula is the normal distribution of a x value of 1.645, with a mean of 0, a standard deviation of 1, and a cumulative of 1, and I get the 95% probability is associated with that x value. And then the reverse of that is if I use the norm.inverse of 95% probability with a 0 mean, I get back 1.64485, which is basically the 1.645. So we've also done this for the student t-distribution and inverse. And you'll see later on in chapters in weeks 4, 5, and 6, when we get to this data, the t-distribution in the extreme, if the degrees of freedom goes to infinity, then the t-distribution becomes close to the normal distribution. So you see here, I did an example here of a degree of freedom of 5 in my equation. Let's see that if the degree of freedom were 500, which is 500 samples, and I hit return, I get 0.9497, which is almost the same as 0.950. And that's because, again, as the number of samples increases, the student t probability or the student t distribution becomes the same as the normal distribution. So that's all. I hope that was helpful and taught you a little bit about how to use Excel, how to use equations, and how to conduct and develop some graphs. Thank you.